Hello. So problem number 664, stranger printer. So what this problem says, we have got one stranger printer that print with following two special properties. The printer can only print a sequence of same character each time, like it can print BBB at once or AAA at once, or at each turn the printer can print new character starting from and indicate any place and will cover the original existing characters. Okay, let's understand this with an example. So let's take one very basic example for this. Suppose here A is given. Okay, first understand the properties of printer. The properties of printer is like it can print something like A in one go. Like this will be counted at one cost only if we talk about its cost. And second is it can print like A, B, C. So like this will be counted as three cost, right? Because it's printing each character cost count is one. But if it can print same character simultaneously, and that count will be one only. And secondly, one and in this only they have given it can override the existing character also. I mean, suppose it has printed A, A at one cost. So in the next, it can go and can override this also. So this is also its property. So now since this will be another cost counted. So previous one, so total cost will be two now. So these are the two properties of this printer. Okay, so let's understand this. Suppose we have taken this example A, B, A, right? So oh, if we print it something like this, so suppose we print first A, then cost will be 1. Again we print B, now cost will be 2. And again if we print A, B, A, the cost will be 3, right? But they have given one property to us that it can bring the same character any number of times simultaneously. So using that property, can we think of something much better solution? For same example, if we see, suppose A is there, so it can print AA, so cost will be 1. Now we have given we can override the existing character also, right? So this we can do. We have overridden this A, so now the cost will be 2, right? So we can see from this is our second approach and this is our first. So we are getting less number of cost from this approach, right? So we will what we will do, we will like use both the approach here. I mean, by printing one by one, this will be our first and this will be our second. And from here, like we will find the minimum of both the approach. Let's suppose we have taken one example, something like A, B, C, and here D, again A, suppose came, again F, G, A, and H, right? So one approach will be like this only, like we can print one character at a time, right? We can print A in the first, in the second part we can print A, B, again in the third part we can print A, B, C, like this. Or in the second approach what we are doing, like it told that we can print the same character multiple time, right? So using that approach only, we will find the next matching character. Suppose here in our example, we have given A, B, C, D, A, F, G, A, H. Suppose here A, so we will find the next A. right? Because they have given we can print like this, right? We can print like this. So we will print all this from here to here in one go only. So what we will do, this part, this A, this A, this A, this A will be printed in one. So our cost will be one. Let's forget this moment. Let's forget this part for a moment. We will like focus on this part only, right? So our cost will be one. Now again, what we need to do in our this part of the array, only this part. If we look only this part, since now this A and this A is already gotten printed, right? Because this A and this A. Now we need to go take care of this part, right? This also we need to print properly. So in the second stroke, what we will do, we will print B, C, D, A. Sorry, this will be A only. So now second, again in the third we will again print C and this will be A. So if we see here, now this will be the third part. 1 minute. So if we see here, this will be the third part. Now for the fourth, what we will do, B, C, this A and this D, this A, right? So as we can see, we have printed from this A to this A, 1, 2, 3, 4, 5 in fourth part, right? So what we are doing here actually, if we see A, B, A, B, C, D, A, F, E, G, A, K. Let's suppose this. Now what we have done, we have find the character which is matching. We are printing them both in one stroke, and what is in between we are printing in another call, right? This what we are doing. So suppose our first matching character here, this we denote by K and this by L and this by R. Right? So we will now this A, B. Suppose we have printed like this. So this A and this A got printed. Now we need to print this. So again we will follow the, now this will be like a separate string, right? Now again we will follow the same approach for this also. So isn't it like something like a recursive call that we are doing again and again? So if we denote by A, B, C, D, A, F, E, G, A, K. So this is K, this is L, and this is R. Suppose this is A, this is K, and this is R. So what this will be? This is L plus 1, and this will be K minus 1, right? And this will be K plus 1, this F, and this will be R, right? So can we say that our recursive call for suppose sol is there, we can print from L to K minus 1 plus, and in the other recursive call we can print from K plus 1 to R. See, why not K? See, if we see here, this A is getting printed with this A only, right? So we did not need to print again here with with like this part separately. This A will be printed with this A only, right? Or we can say like this also, something like L plus 1 to K plus solve for K plus 1 to R. Now we are thinking the same thing like in reverse. Suppose in the first what we think A B C D A F E G A K, this is L and this is K and this is R, our, right? So in this approach what we are doing, we are printing this A with this A only, right? So we will not include this A separate, we will not include this A like in our rest of the calls. And in this what we are doing, we are including this A while printing this A, right? So we will exclude this A in our second call and it will be L plus 1 to K plus solve for this K to R. So both are correct. We can write like any of this. Either this also, solve from L to K minus 1 plus solve for K plus 1 to R, and this is also correct. We can solve for L plus 1 to K, and next we can solve for K plus 1 to R. Both are correct. We can write either of them. But just we need to keep in mind that we will be including only one A, not both. Now suppose there our problem statement will something like, suppose A, B, A, and C will be there, another A will be there, and D, E, F. So what we have done, we are like just checking who's like which character are equal, right? So one way will be something like A, and rest of will be like this only, right? So one path will be something like this. Another path can be something like this. This A is also matching with this A, right? So we can also do something like this also. This is another path that we will take. Right. So from both our answer can came right. For example, from this path we are getting answer 1, and from this path we are getting answer 2. So there can be multiple possibilities, right? Depending upon the presence of K. So we will look for each character like A, B, A, C, A, D, E, A, F. So we will look for each character. This A also, this A also, and this A also, and we will find the minimum of all this path. Like if we see here, for this example, minimum will be this, right? Suppose if we try to code this like A, B, C, this our example was A, and again D was there, again A, and suppose F. And if we take this L, and if we take this R, so what we have to do, we need to first check which are the matching character, which our like first what we need to do, we need to check which is our the matching character, right? So we will apply a loop from int I L to R, and then we will check if s dot caret L equal s dot caret K, then we will apply our recursive call. We can apply like as we have discussed, we like two approaches are there, like this one is the this one is there and this one is there, so we can apply either of them here. So it will be like, suppose I apply this one L plus 1 to k, and another call will be from k plus 1 to r. Or we can also do something like this also. We will l, then we do not need to include another a, and then solve for k plus 1 to r, right? And since there can be multiple paths, so what we will do, we will file the min of all those paths, right? So we will take one min, we will declare one min, and we will find the min of all those paths, since like uh, there can be multiple case, right, which which will be matching with our l, which will be matching with our l character. So minimum of this, min of all those, math dot min of all those. So this is our first approach, and another approach will be our default approach. Like in that approach, what we are doing, suppose a b a c is there, so as we have discussed, we are printing it one by one, right? So for that it will be a simple, like suppose this is l and this is r, so we will print it one by one. So suppose we are printing this one, and we will solve for rest of the function, right? And base case will be like if there is only one character left, if l equal r, then in that case obviously we can, like, our cost will be 1. And in any case, if l our l crosses r, then no character left, then we will return simply 0, right? So let's sum up down what we have just written in the code part. Now suppose we draw the recursion tree for this example. So let's suppose take a b a c, and these are the indexes 0 1 2 3. So what will be the recursion tree if we split it, since we are comparing the numbers? So we can say here the splitting will be something like this, from 0, this part will be from 0 to 1, and this will be 3. Why not 2? Because if we see here, this a and this a are already printed, right? This a got already printed with this a, so we will not print it separately. That's why. And again, if we split it further, so this will be, I mean, this will be AB, and this will be only C now. So it will be like 0 0, and it will be 1 1, and this part will be 3 3 only. So this will be A, this will be B, and this will be C. So as we can see, only one character remain. So what is the cost for printing this character? This will be 1, and this will be 1, this will be 1, right? So if we sum these two, 2, this is 1, so total will be equal to 3, right? So that what will be like return from here 2, and from here 1, and total will be 2 plus 1 equal to 3. So let's get back to the code part of it. So if you are seeing that my recursive function will be like this, which will contain one sol, L and R, and string S. As we have discussed, the base case will be if L equal to R, it means only one character left, then obviously the cost will be 1. If L is greater than R, it means no character left, then we will return something like 0. And this is our default case in which we are printing character one by one, right? That we have discussed. We are just taking one thing, just we are taking only one character, printing it, and then we are solving for the rest of the string. Now this is our the second approach that we have discussed, in which we can print characters simultaneously, right? So what we are doing, we are starting from k equal to l plus 1 to r, and then we are checking whether l is equal to k, right? And then we are solving for l plus 1 to k minus 1 in for the for the first recursive call, and the second recursive call will be from k to r, right? So let's suppose like here what I'm doing, let's suppose a b c a is there and d e f is there. So we will match the first character. This matches with this l k. Now we will solve for this, right? So this will be something from l plus 1 to k minus 1 plus, then we will solve for k to r. Why k to r? See, in this part we are not including this a, right? Because we are going from l plus 1. This is l, this is l plus 1, and this is k minus 1, right? So this recursive call is for this string b to c, and since we have excluded this a, so what we are assuming, we are printing this a with this a, right? When this a will be printed, then when this a will be printed, then obviously this a will also be printed, right? So that's why we are printing it this. Also we can say like this also for the same. If suppose a b c a d e f, if we are printing this a, then we need to exclude this a, because in that case this a will be printed with this a, right? So in that case our call will be from l to k minus 1, and plus it will be from k1 plus 1 to r. This is also true, right? Also we can say like this also. There can be another way of saying the same thing in l plus 1 and k, right? Since this is l, this is k, and this is r. So what we are doing here now, we are including this a, so it means this a will be printed with this a, right? And plus we will solve for rest of. So so all these three are correct only, so they are just basically the different version of saying the same thing. See here, we are iterating from L plus 1 to R. We are matching our like character, and we are printing from L plus 1 to K minus 1 in one recursive call, and from K to R in another recursive call, and we are finding the minimum of all possible paths, right? That's what we are doing. And obviously the state of DP will be LNR, and we are m- caching it and memorizing it. So for future LNR, for same LNR, we need not need to recalculate those values.